Okay, so we're gonna get started. This is the first lecture of our course. We're gonna talk about the requirements engineering problem in general. All right, today's gonna be a light lecture. It's not gonna be a full lecture again, just to ease you into the course. Some of you are still in vacation mode, I'm sure. So, and some of you are. Well, I can't say you're shopping because it's a core course. You can't really do the shopping per se. But anyway, oh, there's one thing. All right, so today we're gonna be looking at the define the goal for software development, describe root causes for project success and failures. And all right, so let's take a look here, some data. And just to build up the motivation for this course and the motivation for this particular field. All right. Now, the Standish Group is a very, very famous group. They do a lot of surveying, okay? Not just in the world of software, but they do a lot of surveying. They grab a lot of statistics for a lot of fields. Could be the medical field, the transportation field, the software field, and education field, and so on. But they're very, very reputable group. I mean, when they go out and do their information gathering, and they give you a piece of information, it's usually a very respected piece of information. It's kind of like a very respected news outlet. All right. Now, what they've done is that they've surveyed a few years ago around 175,000 projects in the IT industry. All right. They realized that in the United States alone, around $250 billion are spent each year on IT projects. That's a lot of money. Okay. Now, when you're spending that much money, obviously, you would want your projects to be a success. Okay, you don't want to be spending all this money. Even a 50% failure rate, or even a 20% failure, 20% of $250 billion is a lot of money. If you want to know that in reals, it's probably just multiply by 4. It's actually 3.75, but if you multiply by 4, that gives you about 1 trillion reals. Okay, in Saudi Arabia, I don't know the numbers, but I can tell you it is not a small number by any means of the imagination, okay? The government specifically, they invest quite heavily. Matter of fact, I can tell you that what I've noticed from the different places that I've lived around the world, including the United States and Canada, and mashallah, that the government here, they invest quite heavily into the e-government platforms, okay? So advanced, you basically click on one thing and it just resounds and it just integrates with all the other systems, and pretty much every feature that one naturally and normally back in the day would expect to line up in long rows. I know it used to be like this here one day, but it's not like this anymore. You go into these government buildings right now, they're all empty, okay? And that's because of this massive investments that they've done in the e-sector. So nonetheless, the point I'm trying to say is a lot of money is being spent. Even a small percentage of failure is still costing us a lot of money. So we want to make sure that we get these projects to be a success as much as we can. However, 31% of these 175,000 projects that they've surveyed have been canceled. Okay, I'm not even saying that they've been challenged or they were delayed, whatever budget. That's usually the definition of challenge. But no, they were just outright canceled. Okay, so 31% of $250 billion is wasted. So that's a lot of money being wasted. 52.7% of these projects will cost almost twice as much as their original budgets. Okay, original estimates. Again, estimates can come in the form of time or money. These are usually the most two critical factors. Okay, obviously the third critical factor is how much functionality are you actually delivering. So when you sign the contract at the beginning, you decide on certain functions that are going to be delivered. Now, one way I can cheat is that if we agreed on 10 functions to be delivered, and I end up delivering just 3 just to make sure I'm within budget and within time. Yeah, I'm within budget and within time, but really I've delivered a lot less than I said that I will be delivering. American companies and government will spend $81 billion for canceled projects. If you do the math, these same organizations will pay $59 billion for projects that will be complete. Now, this is what I'm trying to say is this is saying that in addition to the original budget, $59 billion are being added to the original budgets. All right, because projects are being overrun in schedule and in budget, that, you know, there's another $59 billion in addition to what was already scheduled and already planned that's going to be spent for these projects to be completed. Okay, and this is not even the worst case scenario. And the worst case scenario is the one that outright canceled. So these are ones that were actually completed, but will exceed the original time estimates. Things have improved in the industry. Okay, and a big part of the reason why things have improved in the industry over the last, say, 15 years is the advent of the software engineering field, which didn't exist maybe 20 years ago. Okay, it was something that existed in academics, but not so much so in the industry. But finally, see the industry starting to come around and saying, okay, no, it's very important that we understand that when we have projects that have a certain size and a certain scale, that we do need to have an engineering process in place. So there's a lot more buy-in now than it was 20 years ago, okay, where you were hired to build software, and from day one, you just sit down and start programming. Okay, whatever project you get, you start programming. So that's not really the case much anymore. You actually do see, if you go to Monster Golf or any of the other job seeking website, and you look for something like a requirements engineering job, you will see a lot of jobs out there. Now, having said so, because I already opened up the subject, is that unfortunately, people from business have hijacked this title of this job. Okay, people who work in requirements engineering. Okay, so if you look at requirements engineering, you just Google it, or sorry, you type it in the search engine, it's not going to get you that much hits. The common term is business analyst. Okay, it's called. So if you, after you finish this course and you feel like, oh, I'm really, really interested in this field, like I was at one day and still am. If you're really, really interested in this field, you know, you like the world of software, but you're not really too crazy about spending 9 a.m. to 5 p.m. every day sitting in front of a computer writing code, and you feel like, oh, this is, you know, a different type of way of working with the IT industry without actually being in the programming aspects of it. This is a very, very good way. And it's also techie. Okay, it's not just generic, I'm a project manager. Okay, that's one thing now you see in the industry here in Saudi Arabia. There is a saturation of quote unquote project managers. Okay, everybody here's got probably a LinkedIn page by now, huh? Okay, guys, right? And every time you open up, you fire up your LinkedIn page, there's somebody who's boasting about they've completed the PMP certificate. I've completed, I'm now a certified project manager, right? And then what they learn is they learn obviously important, but generic project management techniques that can be applied to any type of project, including software projects. So you see that the manager is actually a mechanical engineer and is managing a software project. Anyway, requirements engineering is still a techie part. Okay, it's still a techie thing, but it's not programming. So a lot of people are interested in this, and it's one of these things that one of these fields where you get to deal with different customers. So maybe for 6 months you're dealing with Pepsi, and another 6 months you're dealing with Lay's, another 6 months you're dealing with Adidas, another 6 months you're dealing with Nike. So a lot of people like that aspect of the job because it provides a break of a routine. Okay, you're not going to the same office every single day and meeting the same people every single time. Okay, so this is part of the job that is quite lucrative, it's quite interesting. And when you actually go and visit these companies, they give you a lot of free gifts as part of working. So you go to Nike, and you get a lot of shirts and t-shirts and then shoes and so on and so forth, right? You go to Pepsi and you get a lot of products for there for free as well. How do I know all of this stuff? Because I have a lot of friends who actually work in the industry in this type of field. All right. A system was built. Okay. However, we can all relate to a project that never went to market. You probably haven't, unless you've heard it in the news that a project has failed. And obviously, because you haven't worked in industry yet, but you will see that a lot of projects would have exceeded their budget and time, and maybe suffering from some quality issues as well. So the Standish Group surveyed the respondents to identify what are the most significant factors that led to projects succeeding, and what are the most significant factors that led to projects failing. All right. And they brought it down to 3 levels: success, challenge, and impaired. So impaired basically means canceled. Challenge mean we got it done, but over budget, all right, or behind schedule, or maybe fewer requirements were delivered than what was originally agreed upon. And finally, success is where you get the all three criteria. You get a full mark in all of these. All right. Now, for the ones who are labeled to be challenged, okay, so we got it. It's not what doesn't outright cancel. Okay, the most common cited factors was lack of user input, worth 13%. Incomplete requirements and specification, another 12%. Changing requirements and specifications, very, very common issue. Okay, also worth 12%. And one of the reasons why we're facing these issues is because a lot of times the customer don't really know what they want off the bat. And this is what I was explaining last lecture as well. Now, if you do the math, add up all those three together, 13 plus 12 plus 12 gives us 7?
37.
37. Okay, roughly one third. One third of the issues that impedes software project and put them under the challenge criteria or even canceled are related purely to requirements engineering. Okay, do you need more motivation than this? I'll give you more. Okay, it appears so one third of the development project run into trouble because of things that are related to requirements gathering, documentation, or management. Now look at the other side of the coin. What are the factors that lead to success? Okay. So although a lot of projects, they run into schedule and budget issues, right? If not outright canceled. The good news is that within the success factor, small companies have a 16% success rate. Larger company have 9% success rate. Because larger companies usually deal with larger projects, and the larger the project is, the higher the risk. Okay, just natural. I mean, if you're dealing with a project that is, you got 10 requirements, 10 people, 10 months to do it, the risk factor is much, much lower than you're dealing with a project that is 100 requirements, 100 people, and maybe even like 5 years to do it. Okay, a lot of things could go wrong in the meantime. Okay, it's almost like the bigger the project, it's almost like in basketball. Okay, in basketball, you're kind of like you're doing an estimate on how to shoot, how much effort I should put on the basketball to go into the basket. Now, the closer you are, the smaller the problem, the closer you are to the basket, it's easier to make that shot. The further you go away, it becomes harder and harder. All right. I mean, if a project is 5 years, just imagine the cycle of people who came into the work and left during those 5 years. Right. So there's a lot of people when the project started are no longer with us, and a lot of people after the project started have joined us are now working on that project. Okay, this would probably wouldn't be the case if the project was just 6 months. Okay, and I think this is the reason why you're seeing that small companies have a higher success rate. Still, 16 and 9% is not the greatest, but let's talk about those 16 and 9% and see, well, how did you get the 16 and 9%? Okay, so we got some good story here, and we're trying to drill down the success factors. Okay, and when they talked to them, the respondents, they said the reasons are user involvement. Okay, so it's funny, it's almost like they are reverse of what we have, because we got 16%, executive management support, around 14%. And what that means is executive management support for requirements engineering to actually be, okay, that's a big culture issue that we suffer from in the software industry, is that I pay you to write software. Okay, what is all this requirements engineering and modeling that you're talking about? Okay, I know, because we get a bad rep for computer science. All right, that they look at computer science and they create things and that's it. So why is it that we should be paying for all this documentation, all these interviews, and all of this is wasted money? The only money that is good and justified is the money that I pay you to write lines of code. Okay, this is the wrong thought process. All right. Thankfully, things have gotten much, much better now than it was back in the day. Okay. I remember working in one company in New York. And their motto was that the code is the documentation. All right, that the code is the documentation.
I have a question.
Yes, of course.
Why large companies accept projects that they know that it will fail?
Money. Okay, so that's easy.
But it will fail. You will lose your money.
Yeah, no, what? The company? No, they're gonna get their money, even if it fails. All right. So the way it works, all right, it's not like it's not like building a cake, getting a cake where you know you build the whole cake and then once you deliver it, then you get the money and then you're good. Matter of fact, if you actually go and you have to pay for the cake even before, but even then. But software projects are really, really big and you need to bankroll them. Okay. And it's uncommon that you'll find a situation where a company, even a big company, will say, all right, keep all your money. Once we deliver and everything is fine, then you pay us. Right. That usually doesn't happen. Okay. So money keeps coming in month by month, installment by installment. Right. Say the project's for 2 years. All right. And let's just say we started to feel like we're in trouble after 18 months, that this project is going down the drain. Fine, we've already made 18 months worth of money. Now, I'll tell you a bit of a different story, and you'll find this even more shocking. And I'm not really commending this at all, but this is something that happens in the real world as well. Okay. And it's especially prevalent in the Middle East because we have the wrong attitude towards awarding projects. Now, if I have a project and I want to award it, I got say 5 subcontractors. Each one of them, each one of you is saying, "I'm going to build this software. This is what it's going to do for you. This is how much time it's going to take. Is how much money it's going to cost. These are all the features. These are all the safety features and the security and so on and so forth." Okay. So each one of you says a number. All right. Usually the higher the number, I mean, there is some aspect to it. Okay. I mean, Mercedes doesn't cost the same thing as a Honda, for example, right? Because you're getting more. But the attitude is, when it comes to project awarding, is that I just pick the smallest number, as in they're all the same. All right. Now, this issue is usually exploited by other companies, okay, for obviously a business advantage. So I would come in, I'm a bidder. And I know in my heart of hearts that this project would need 1 year, right? Maybe 1 million reals to complete. I would say I'll finish it in 6 months, 500,000 real. Okay. Completely lowballing the entire industry, the entire competition. You know what lowballing is? Okay. Lowballing is that when you make a bid that is so much lower than everybody else, right? That you completely take all the attention and there's no way that the person who's awarding the project can look or pick somebody else other than you. Okay. So you're building a building, you said 1 million real, 1,200,000, 1,500,000, 1,300,000, and then Sarah comes here at the end and says, I'm gonna do it for 150,000 reals. Okay, you're gonna get the project, right? But it's not the right approach because it's gonna blow up in my face at some point. Okay. Whatever's gonna cost you to make it 1 million real is there's definitely more to it that you actually made that estimate to begin with than 150,000 real. But this is what happens. They say, well, let me just get the project first. All right. 6 months later, we'll let them know that we need more time and more money. What are they going to do? Okay. Now we can go to courts and all this stuff and it's going to drag on for you. But is this really what you, are aiming for? Because the reason you actually gave me the project is because you're going to benefit from the software being developed. Okay. Right. That software, after I deliver it to you, is going to save you a ton of money every year. Now, if you're just going to pause the project and just go to the courts and have all these big fights, you're still losing money because this project is not being completed. So one approach is to say, "Khalas, the heck with it, just fine. Here's a little more money, here's more time, just get it done." You have a question?
Yeah, so the client won't get their money back.
No, I'm not.
Is the client paying in increments or?
Usually they pay in increments, yes. All right. Now, even clients are not angels. Okay. So what happens in a lot of projects as well is that the last increment is supposed to be paid when the project is completed, Usually clients will say, okay, I'll pay you next week, pay the week after, I'll pay you next month, pay you next year. And then it keeps dragging on and on. So neither client nor vendor are angels in this regard. As an academic, as a professor, I'm supposed to say that you should uphold your ethical and moral values throughout this whole process. God be with you when you actually do hit the industry, because you're gonna see this nasty work happening. And I'm glad I'm working at a university so I don't have to deal with this. All right. So yeah, so then yeah, you get another 400,000 reals and maybe another 4 months to complete the project, and yeah, right, and the project is completed. Although from day one you knew it's not going to be 6 months, and you knew it's going to be a lot more than $500,000, right? If you're going to say no, I'm going to be the angel, then okay, fine, but you're going to keep making bids and somebody else is going to outbid you, right? And then you're bankrupt. Okay. So I mean, being in the position that you have to make money decisions is definitely not. I mean, none of us are in software engineering to be put into that position, but yeah, that's the world we live in. Okay, we don't build software for funs and giggles. It's a business at the end of the day. Okay. A clear statement of Hessel, do you have a question? I thought you. Okay, sorry. A clear statement of requirements. Okay. That's usually the holy grail of any product for success. Okay, it's starting off with something like, okay, just tell me what you want. I mean, imagine you go into the cake shop saying, I want something that's gonna make my daughter happy. Yeah, but what is it? Okay, I don't know. She likes things. Okay, give more information. Give me even one word. Okay, ponies. Okay, fine. We can unicorns. I can deal with that. Okay, but obviously, the more clear the project statement is, the problem being stated is, the more specific your solution is going to be, because you're addressing the specific problem. Okay, 4 plus 4 equals 8. Okay, positive number plus positive number equals, huh?
Positive.
Yeah, but you have to give me a concrete solution, right? So you're gonna say 15, right? Yeah, it's correct, but it's not really the number that I have in my mind. Why? Because I gave you an ambiguous problem to begin with. Yes.
Some of the clients don't understand that they need to give true requirements.
Yeah.
That's the problem. Like, okay, let's say a client came to you, your program or whatever, a developer, that's it. He came to you and he was like, I want a program that has like, I don't know, programs each card that enters the Python.
Okay.
And he didn't give you specific requirements. Like, okay, each program is like this. Counts the cards, but what do that? What else does it do? Yeah.
All right. That's actually more detailed than I would actually imagine. Okay. Now, usually the customer, the big, the upper management would say, no, they don't know, they wouldn't know, first of all, and frankly, they don't care. Okay. What they know is that their business could benefit from using software, that their business could benefit from using a much more updated, more, better software. Okay. Like, I could look at my website and say, this looks old. I need something more flashy. Okay. That's as far as I can go. Okay. You're going to come to me and say, okay, well, what is it that you want on your new website? I don't know. I want it to be like what the new people do. Right. It's almost like fashion. Okay. It's like, I look at my girls like, I look like an old man. I want to look younger. But what is it that actually involves, the trends that, 20-year-olds actually wear nowadays? I don't know. Right. And this is why you see celebrities, they actually hire a person who deals with the wardrobe, because they want to know. They know they want to look cool and trendy and all this, but they don't know what exactly to buy and what to do. Now, these are the success factors. Okay. If you add up the math, 16, 14, and 12, 42. Again, that's almost 50% of the reason why projects have actually succeeded. It's related to something to deal with requirements. All right. Do you need more motivation? I'll give you more motivation. No worries. Okay. Now, back again to software development problems. Okay. this is at the bottom, you can see kind of like the waterfalls life cycle. So things that are related to requirements and their specification and their documentation. And then we come down here, we deal with the design and so on. And then we come down and we deal with coding, right? And we always have this imagination that the trouble that software companies are dealing with when it comes to coding, just a moment, make sure that, oh, that's fine. Because we suffer through SE 100 and SE 120 and SE 220, and we think that in the industry, people are actually sitting in front of their computers getting null pointer exceptions, and the static variable that you're trying to access from a non-static context, which is still, we have no idea what the heck it means. All we know is that there's a little red squiggly line, you click on it, and it makes the name of the variable with a capital letter first, and when we do that, suddenly this error goes away, and then we're happy it's compiling. There's 20 minutes left for the assignment to be submitted, so I'll submit now and we'll figure it out later, which you never did. All right? This is what happens, right? In reality, okay, you suffer through this. It's kind of like riding a bike. You suffer through it to learn it. But once you've learned it, once it clicks, خلاص, you understand this whole object orientation stuff, okay? You never, A, it's like riding a bike, you never forget it. And B, it becomes second nature to you, all right? You never actually walk by somebody's desk in the industry and you actually find them getting a null pointer exception error. That actually doesn't happen, okay? So you just get really, really good at it. And basically what differs one programmer from the other programming is what libraries are you familiar with, okay? Are you familiar with the networking libraries? Are you familiar with the Java FX libraries? Are you familiar with, you know, the C# libraries, okay? The internet programming libraries, okay? It's which ones you've dealt with the most, all right? So I'm supposed to, yeah, there we go. Sometimes you gotta push it with the finger just to, right? So when we look at it, okay, you see there's a gray box, a black box, and a white box. So the gray box is where we have a major problem, and the black, a minor problem, and white is never a problem. And you actually see that at coding, the white bar is very, very high, along with the minor problem as well. Whereas coding actually being the biggest issue that we have in our software development is rarely the biggest problem in itself. But when it comes to the first two categories that are related heavily to requirements, you'll see that the gray bar is actually quite high, okay? And then also, inversely, you look at the white bar, it's actually very low. Okay, so it's almost like guaranteed that every project you're gonna be facing problems with our requirements, okay? You need more motivation. I'll give you more. Oh, so the first one says requirement specification. Second one says managing customer requirements. Okay, requirements management is something I'm going to cover at the end of this course. Okay, requirement specification in general, the whole requirements engineering process is something that we're going to be covering obviously throughout the entire course. All right. You had a question?
Give me more motivation.
Yeah, giving you more motivation. Okay, so let's take a look here. So the two larger problems to be are but half of the problem are responses related to software specification, management, customer requirements, coding issues were a non-problem, relatively speaking. Okay, here's another motivation. Okay, getting things right first time or at the requirements phase really, really pays off. Okay, if you say the cost of a bug is worth 1 riyal, okay, if you do find it, sorry, at the coding level, 1 riyal at the coding level, had you actually found that same issue that had leaked in from the requirements, okay, in other words, it was the coding issue, it was actually result from getting the wrong requirements. Had you fixed it at the requirement stage, it would have cost 1/10, okay, or even 1/5 of what it cost me at fixing it at coding. And if you look downstream, all the way down to maintenance, meaning that the software is already out.
Yeah.
It's in operation. It might cost me 20 times as much. Okay, and it's not just financial cost, it's intangible cost as well. You know what the word intangible means? Okay, tangible means it's something that you can't put a number on. Okay, like bad customer reputation. Okay, sorry, bad customer satisfaction. Okay, or bad reputation. You know it's gonna hurt you. You know it's gonna hurt you. You just can't put a number on it. Okay, you just can't put it in an Excel sheet and say minus something something, right? But you know it's gonna hurt you. It's intangible. All right. But again, we've muddled a couple of issues here together. Okay, because we're going through the development life cycle. We got the R requirements followed by the design, implementation, testing, and so on, right? There is a distinction between the error actually happening at that phase, whatever it is, could be the implementation phase, the coding phase, or it could have leaked through from earlier phases. Okay, that's actually the worst scenario. Okay, so remember when I was saying last lecture, somebody came and said, I wanted to have a colorful car. They were ambiguous. Okay, person thought they wanted blue, although they really wanted red. Okay, so once the person at the car showroom writes down blue, this is where the problem already began. And then it just keeps leaking through the different phases. Okay, design team designs a blue car. The implementation team creates a car that looks blue. Testing team checks that it looks blue, and so on and so forth. All right. That's called a problem leaking. And as this problem leaks, its cost becomes higher and higher to fix it downstream than it is to fix it at that stage. Okay. So after testing, you looked at the car and you realized, okay, it's not really red. You have to do a lot of rework. Okay. But actually before that, your first instinct, and sort of like what you're hoping for as well, is that what if the error that we're seeing was not all the way up from requirements? It was actually something that I've done when I got my test failed, something that I actually done wrong in testing. Okay. Yes, the error can actually happen in coding, it can happen in testing. It doesn't have to have leaks from the above. Okay. For example, how is it that I can give you an error about testing where the error is in the test itself rather than the errors in the code? Okay. So I am the tester. For some reason, I misunderstood what the software is supposed to do. I thought it was an addition software where it was actually a multiplication software. Okay, so I give it a 3 and a 2. I'm expecting it to give me a 5. Instead, it gives me a 6. So I say, uh-oh, I found a problem. Okay, the first thing that I should do is, before even looking at the code, seeing why it actually gave me the 6 instead of the 5, I'd maybe say, maybe I misunderstood that. Maybe my testing itself is wrong. And in that case, it would have been. Okay, so here we are, we fixed the test. Oh, okay, oh, it's supposed to multiply. Yeah, it's supposed to actually give me a 6. Okay, got it. Thank you very much. All right. Now, if this wasn't the case, like it was actually supposed to be an addition, but it still is giving you a 6 instead of a 5. Okay, this is where you start to knock on the door of the programmer, one level up, and you say, this is happening. Why is this happening? Okay. First thing that the programmer is going to do, they're going to assume that maybe the mistake is at their place, and you start putting all this effort. Again, it's still effort being exerted just to figure out the problems with you or somebody else. And then they'll spend their time. After maybe 2 days of working, say, I can't find anything wrong with the code. It must have been the design that I was given that I've implemented. Because what the programmer is doing, they're checking against the design. Okay, so we go up. The programmer goes up to the designer, knocks on their door. Okay, it says, we're having this issue. Okay, the test looks right, the code looks right. Did you actually design this wrong? And we're speaking about the perfect world here. And the designer will say, oh, well, maybe. Let me check. And the designer spends their time checking their own design. Spend some time we're doing this. All right. Comes out later on saying, I can't find anything wrong with the design. According to the requirements that I was given, okay, it's actually working just right. I've designed it just right. So this is where we finally go up to the requirements. Check the requirements. The requirement says something, and even then we couldn't find anything wrong with it. We go back to the customer, and then the customer says, oh, no, wait, I actually meant red car, not the blue car. Okay, so it took us actually time and effort just to realize that the problem was at the requirements. Okay, let alone fixing the problem and how much that cost.
In small projects, like this whole process, how many days or months did it take to just like find a small tiny problem?
I mean, I hope by the word small that it's actually doesn't even need an engineering process to begin with. So remember, the word engineering is all about scale. Okay, if I'm building a desk, I don't really need to be an engineer to do it. All right. So here's the thing. I mean, a lot of these things that we're going to be talking about in the next 2 years, this year and the next 2 years, they're all going to sound like an overkill. And you're going to be sitting here thinking that why we're learning all this seems like way much of an overkill, but it is because all the projects that you're dealing with in a university are still rather small. Even your capstone will still be small.
It's small as in just like the example give the car.
Yeah.
They said that they're building a car and they found the problem.
Yeah.
The process of finding the problem, how many days or months?
Oh, obviously it depends on the nature of the project and what is the actual.
Like mostly.
I don't have the numbers, the statistics for it, but I know in theory that before the tester says something went wrong, uh-oh, we must have gotten the requirements wrong. No, they're not gonna do this. They're not gonna raise that flag. All right? It's kind of like a doctor saying, you know, oh, you had a cough, you have cancer. No, they don't do that. Okay? They say, okay, maybe it's a cold, maybe, right? And then what they do is they go through the different processes until the qadar Allah, they have to determine that it is in fact messing something that's really, really a lot worse than it is. Okay. That's how it goes. So the tester doubts themselves first, right? And then they go to the code before they go into the coder, and then the coder doubts themselves first. But even that process takes time and effort. Okay, maybe it will take us 2 months to realize that we actually got the requirements wrong. Okay, I'll tell you another story about the frustration of requirements changing, right? So there was a company, software company in Palestine, all right, and they had a customer who was this French customer, and you know, they were given obviously a good price and so on and so forth. So the French customer was dealing with them and so on, and the French customer was loaded, right? Money was not really an issue, right? So they would get ambiguous requirements and unclear and incorrect and so on, and you know, they want to make some money, so they start working on the project. Okay, a few months later, as it goes, and they start to build the software product, the customer looks at it and says, yeah, I like it and so on, but it's not really what I have in mind. Can we make such and such changes? All right. The software team will say, well, this, but you told us something different. I say, yeah, I know. Fine. I'll pay you more for it. Don't worry about it. Okay. So they get the more money and they keep working on it. And you know, another 6 months would go by. Another 6 months would go by, and they bring in the customer, and the customer looks and says, I like it, but it's not really what I have in my mind. I wanted something different. I want something this. And they'll say, well, this is not what you told us. I say, I know. I'll give you more money. All right. And that cycle kept going on and on. So basically, the customer kept changing their mind and paying for it, and they're happy to pay for it. And the software team kept changing the product accordingly, right? At some point, the morale and the company got so low. Imagine if your job was to go to work and just keep pushing on a wall that it's never going to move. You're getting paid for it, but you're just pushing on a wall. You feel dead inside, like you're not actually doing anything, although you're getting paid for it. All right. So at some point, they decided they canceled the project. They said, Khalas, keep your money. We don't want it. I mean, the idea of just working on something that is never maturing, is never developing, in itself is just such a morality killer. You had a question?
The error was in the code.
Yes.
Would it be the customer or the company?
The company in this case. Who would pay?
Yeah.
Now, that's a very tricky question, all right? Because there's two phases. There's, while it's still in-house and we're developing it, you're supposed to develop something that is error-free, all right? Once it hits, okay, before it hits the industry, or before it goes to the site and becomes an operation, there is something that is science called an acceptance. We do something called acceptance testing with the customer. In other words, for the customer to accept the software. Once they sign it, halas, okay, the development project is finished, the maintenance contract kicks in. And be sure to get that maintenance contract, because that's where the most of the money is in. Okay, you can spend 6 months development, 5 years maintenance. Okay, so make sure you do get that maintenance contract. Now, if there's something that needs to be changed, change can happen because of a bug, change can happen because of other reasons. Okay, it doesn't matter, it's still a change. And every time I'm going to come down there to make a change, the customer pays for it. Okay, that's just the way it is. And you know, Q obviously a lot of the unethical issues of you know, fixing things that are not really required to be fixed, and putting in some back doors for things to fail a little later on. It's kind of like when you take your car to the mechanic and then they fix something but they break something else, so that you come back a couple of weeks later and so on and so forth, right? These sort of things, unethical, that does happen, right? But if you think about it also from a car perspective, right? So you bought the car, obviously as you're buying it, it should be working right? I mean, let's just say it's more as up to the way, okay? Or the brakes are not working that well. You can just at the showroom say, the brakes are not working well. Give me another car, right? But as you buy it and you start using it, now it's yours. And if something's not going well with the brakes, you pay for it, okay? So, you know, a lot of your questions are focused on the money aspect. That's really concerning, sure. Not the reason why I thought students would be signing up for a software engineering project. Guys at home, do you have any questions? I sort of like forgot about you for a moment. Any questions at home? Okay, all clear? Okay.
All clear.
So we've already covered this one. I detected you. Yeah. Yeah, okay, so finish all this. Let's go, yeah, okay, and all right, so as we're saying here, okay, as when we find out we have an issue, we could be doing some retesting, recoding, redesign, or respecification. Best case scenario that we got the test wrong. Worst case scenario that we have to rewrite the specification again, because rewriting a specification is not where the job is done. Okay, so you wrote the specification again, but then you have to redesign again, and then you have to recode again, and then you have to retest again, and so on. All right. You submit a whole bunch of what we call change orders. This is a whole project management stuff. So it's kind of like, it's a little like note cards. Used to be physical back in the day. Obviously now it's all software and automated. And then a team would look at it, and then they have to judge they do something called an impact analysis, because we already have a system. Now you're saying we got to change something. And it's kind of like this building. Okay, so I'm going to move this column from here to there. Well, that's not an easy decision. If I'm going to move it, maybe it's going to make the whole structure unstable. Same thing actually exists in the world of software as well. I mean, you take one class or you take one function and you completely change it. That might actually flip your entire software completely, right? So you got to be very, very careful. And then hence comes in something called regression testing. Is not part of this course, but it's kind of like making sure that what you've just changed didn't mess up everything else. All right. Fixing the error could lead to scrapping useless code, design and test cases, recall of defective software. Now, if it's just software, right, you're not gonna send back a copy of, say, Microsoft Word. It's just software. It's silly, right? But what you do is, after they realize there's some problem that we've got, then okay, then a report is being submitted. Microsoft is now aware of it, and then they send you what we call a patch. Okay, a patch, software upgrade. Okay, a patch is a little just extra code that you add to the additional code. And obviously, a software upgrade is just you removing the old version completely and putting in a different version. And you should be updating all of your software when a company says, we've got a new software, please use that. Every piece of software is a security risk. Okay, and if you keep the old versions, you're keeping the old threats to your risk. Okay, once a lot of the times when they do the upgrade, it's not just for features, but it's also to close the loop on a whole bunch of security threats as well. Adobe and Adobe Flash was one of those softwares that have nothing related to do with security. I mean, one is about Adobe Reader, just reading PDF files, where you figure out like what's the big deal. But there was a whole bunch of security issues that related to Adobe. And if you don't update your software, then you're leaving the threats still being there. Okay, so they fixed it and they told you please upgrade so that we block that threat, but you decided you don't want to do that because maybe laziness, or maybe you have a different software that only deals with the old version of that software. That's actually a common reason as well. All right, sometimes we do this with our iOS applications. All right, yeah, sometimes we do with the iOS applications because the phone that we have, we can't download the new iOS on it. So we say, if I updated the app, it's no longer going to work. So I'm going to keep the old one. Warranty cost, product liability, customers can sue for damage. Although this is rather uncommon, okay? All of us have experienced this at some point when you are downloading something, or whether it's an app or a software that you have on your laptop, right? And you see this big pop-up that comes up with a whole lot of text in it, right? All this law jargon that you have no idea what it means, and then it says agree. Yeah, we just click agree, right? What that jargon actually says is that we did the best that we can to make sure that this is working right, but if this thing blows up in your face and you lose all your money, you lose your family, you lose your leg, we're not really responsible. So proceed at your own risk. And once you click accept and I agree, then, right?
Why they put that long? In terms of conditions?
Say what?
Why they put it that long? In terms of
That loud?
that long?
That law, because there's a lot of law clause. They don't want to be sued, okay? And it becomes a standard thing, right? And it's a lot of jargon that even if we try to understand it, doesn't make sense to us. But basically, like I said, what it does, but we're unique. I mean, life is harder for us as software engineers versus other types of engineering, like civil engineering and mechanical engineering and so on, okay? Where, if a bridge falls or a building falls down, you can actually sue, all right, for malpractice. In software, we have it more difficult in the sense that it's hard for us to do our job, but also our get out of jail free card is that sense that saying, because it's such a difficult job and software is virtual and the damage could never be controlled, we can never guarantee it's always going to, like a building, you can mathematically guarantee nothing's going to happen wrong to it. But software, you can never, okay? How could you prove that a software is defect free? It can't happen. You can prove the presence of a defect, but you cannot prove the absence of defect. So, but we do get away with putting that clause in, and it's your best friend as a software developer, okay? Because he's saying, well, yeah, if the plane goes down, we're free, okay? We're not going to go to jail. You might not get the next contract, but at least you're not going to jail. All right. Same thing with the cookies thing. Every website that you get on now is like, the cookies are acceptable. Now, the cookies are there. Companies use it for legitimate reasons, okay, to speed up your browsing speed and the preferences and so on. Hackers use it to get this information about you, and maybe even sometimes sell it to somebody else, okay, or steal sensitive information about you, all right? So the whole commission about information security in Europe and in the United States and so on, after all of this deliberation about malpractice, they all come down to saying, all right, a website has to say, do you accept the cookies or not? And basically, if you say no, right, then it doesn't use cookies. You're not out, actually, okay? It just is not gonna use cookies, okay? So maybe your browsing is not gonna be as customized as supposed to. For example, you like, every time you go into that website, it has the red background instead of the default black background. Now it's not gonna remember this about you. So every time you go there, it's gonna be the black background and you have to change it back to red. Whereas if you decided to keep the cookies, then it would have been the, but everybody here presses, I accept, all right? And then once you click accept, then we're back again to Rima Adat al-Adima, okay? Then we're back again to that you've been exploited for, yes. So what's your name? Nora, I know that.
What type of information does the website keep?
Cookie have?
Yeah.
Yeah, we're stealing away from SE 324 here, but usually what it has is it has preferences. A lot of times, like you know, the size of the fonts and the colors and so on and so forth. Now, if it's a website, say about cars, okay, let's just say it's BMW, all right, and it knows in BMW you like the X6 model, okay, so maybe next time when you log in, it figures out that you like X6. Now, cookies are two types. There's something called a session cookie, and there's a permanent cookie. So a permanent cookie stays with you even after you close the website. Session cookie is kind of like they hold up to information that, because as you go from one page to a page, you're reloading everything again. Okay, so instead of losing everything, then you keep that cookie. So a very classical use of a cookie is the shopping cart. As you're moving, you don't want to lose, you know, I clicked that book, I clicked that shirt, I clicked that. So it keeps taking along with you. So it's stored in that cookie. Okay. Now, if you click X on the website and you leave it, then khalas, you just decided you're not going to take, then the session cookie is gone. Okay.
How is that dangerous? Like the information that we're mentioning now are kind of stuff that was like our like these can.
It's dangerous only when there's two aspects to it. It's dangerous if the cookie happened to include information that is sensitive. Okay, يعني مثلا if for very bad design, somebody puts your username and password in the cookie so that when you go into the website again, it knows you, it recognizes you, right? That could be dangerous because somebody can then pick, right? So obviously a good countermeasure for that is that you have to hash it. You know what hashing is? Remember hash functions, right? And basically it's a function you put in the regular text and it produces some junk that nobody understands unless you have that hash again, and you can revert it back again. And all passwords are actually stored like this. Okay, so your password on your phone or your Windows is stored as a hash rather than just plain text. The other thing that is a danger, not life danger or anything like that, is that your information can be, your preferences could be stolen. Okay, so you went on this website, you clicked on, you know, this red shoe, like you know, because at some point you liked it. Okay, you just decided to now that website takes it, sells it to somebody else, to a whole bunch of other companies who sell shoes, and they say Noura likes red shoes. Okay, and then they keep hammering you with advertisement, boom, 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 red shoe, until finally they say, "Khalas, fine, I'll buy a red shoe." Okay, this is another way they get back at you, and these sort of things are just it's just crazy. And obviously, social media just blown this out of proportions. You know, for example, everybody's like always afraid to click on an advertisement, say of a bag, handbag, because they say, "Oh, I'm gonna get hammered with it." With advertising. The fact is, if you're scrolling through your feed and you pause, you didn't click, you just pause on the picture of the bag, there's a timer on the back end that sees how much time you've been looking at this bag. And if you exceed a threshold, it understands that you like that bag. So just the fact that you looked at it for about 5 seconds and then decided to keep scrolling, not click on it, it still figured out that you liked it. And then hence, cue all the people on Facebook saying, I swear to God, they're they must have been listening to microphones. And no, they're not. It's not that sophisticated. It's just that you've been looking at it for some time. There's a timer that realizes that you had the handbag on your screen for a certain amount of time and realized that you like it.
When I click remember me, when I don't get
Yes.
this is the cookie.
It would be a poor design if it had been stored as a cookie. All right. Now, there's obviously security is a cat and mouse game. Okay. So one day it was based on cookies, but that no longer, now cookies are, the word cookies now has become infamous. Okay. It just has such a bad rep. So companies now are resorting to newer approaches to remember you. Okay. Better side on the better err the side of caution and just get you to log in again than it is to remember you, right? So yeah. Oops. All right, so any questions about this chapter before we conclude it? All right, so I'm gonna put up a YouTube link. I'm just, oh, there's somebody, there's a lot of people talking. Oh, same thing, okay. Okay, so guys at home, in case I do miss a text and you feel like I'm not responding, and it's just because I'm not actually seeing the text, I have the speakers turned on. So if you want to ask me a question, just speak into your mic, and I can hear you, okay? And this way you can get my attention. Having said so, please be sure that if you're not going to be speaking to me on the mic, then make sure that your mic is muted so that it doesn't pick up. But I'm seeing all of you, mashallah, you're doing a good job at this. All right. So I'm going to put up a YouTube playlist. I have the channels already up there, but I'm going to put a playlist for this course, SE225. And then you're going to see go to lecture 1, lecture 2, lecture 3, lecture 4, and so on. All right. Okay. I'll see you next week, inshallah.
Thank you.
Thank you, doctor.
Thank you. Thank you.